The non-homogeneous equation, same process, because we're gonna use the method of variation of parameters. Well, have 2 minutes, but if you have like 5 minutes, I can finish one problem for you. But if you have to go, feel free to go. You can follow up with the recorded session. Now our problem, our equation is the Cauchy Euler, which the coefficient would be the function as a power form, the x squared, x, and so forth. 5 steps remain the same. You find the complementary solution. Okay, using the way to find for the Cauchy Euler. Compute the Wronskian. Use in the standard form. The standard form here, you have to work a little bit more than the constant coefficient. And use the f of x to find w1, w2, find u1, u2, u1 prime, u2 prime, and so forth. And then the solution yp is the product of u1 and y1 plus the product of u2 and y2. The process exactly the same, except the first part here to find y1 and y2. That's it. Okay, let's work on this one. All right. It would not take long. Again, if you have to go, I understand. So this is Cauchy Euler. Okay, Cauchy Euler, because second order, second power, first order, first power, and non-homogeneous. Okay, non-homogeneous. Step number 1, we're gonna find YC from the associated homogeneous, which is from x squared, y double prime, plus 5x, y prime, plus 3y equals 0. And make a list. Our A is 1, our B is 5, our C is 3. Okay? The auxiliary equation, the A, which is 1, multiplied by m times m minus 1, which is the coefficient of the second derivative, plus the B times m, which is the coefficient of the first derivative, plus C equals 0. This is a critical part right here. And next, you're going to solve the quadratic equation. Expand them all out, collect like terms. M squared minus m plus 5m plus 3 equals 0. Simplify to be m squared plus 4m plus 3 equals 0. So m plus 3, m plus 1 equals 0. It looks like we have done this before, right? M equals negative 3, m equals negative 1. All right, displaying real roots. Oh, it didn't go. Just keep. Now I figure it out. I have to give word problem, give word application for 1 or 2 seconds, and it will put together for you. Otherwise, it kind of broke them apart for you. So m equals negative 3, m equals negative 1. So the solution, so y1 is x to the power negative third, and y2 is x to the negative first. Okay, you can write it as the negative power or write as a fraction, doesn't matter, but I would keep it as the negative power because we're gonna have to find the derivative when we work on the Wronskian and so forth. So the next one, next step, same thing as what we did earlier at the variation of parameters. The next step, we're gonna find the Wronskian of y1 and y2, which is the determinant of the 2 by 2 matrix. The solution 1, solution 2, the derivative negative 3 x to the negative fourth, negative 1 x to the negative second. For the determinant, you get negative x to the negative third multiplied by x to the negative second. Subtract another negative sign become plus sign, 3 x to the negative fourth, x to the negative first. Combine the exponent to get the power as x to the negative fifth plus 3 x to the negative fifth combined to be 2 x to the negative fifth as w. Okay, set it aside. Oops, again, give it a second. Step 2 is done. Step 3, standard form. From x squared y double prime plus 5x y prime plus 3x no, plus 3y, sorry, equals x to the second, divide all by x squared. To get the equation as y double prime plus 5 over x times y prime plus 3 over x squared times y equals 1. Okay, we're gonna do based on this standard equation. And this standard equation tells you f of x equals 1. Okay, if f of x equals 1, we're gonna use, oh, where did it go? Don't go away. Okay, there you go. So we're gonna use f of x to find the W1, 2, 3 for the next step. So next step number 4, your end goal is to find U1 and U2. Before you get to U1 and U2, you're gonna need W1, which is the determinant, the first column, right? 0, f of x. Second solution, which is x to the negative first minus x to the negative second. And the W2 is, the first column is the same. Second column is 0, f of x. Determinant is nice when you have 0. So crossway down, 0, crossway up. Let me replace it. Since f of x is 1. So we get negative x to the negative first, or negative 1 over x. Let's see which form is more convenient for the next step. And then for the W2, x to the negative third, negative 3, x to the negative fourth, 0, 1, equals, determinant going to be x to the negative third, or 1 over x to the third power. Next, we're going to use W1 and W2 to find the U1 and U2. So the U1 term is W1 over W. W1 is negative 1 over x. And what is W? W is 2 times x to the negative fifth, right? So W is 2 times x to the negative fifth. Maybe write it as negative. So negative x to the negative first divided by 2 times x to the negative fifth. So we have negative 1 over 2. And x adjust the power to be x to the power. That becomes power 4. Then the U1 antiderivative of negative 1/2 x to the fourth with respect to x. And we get negative x to the fifth over 10 for the W1. And then the U2, W2 over W. W2 is x to the negative third divided by W, or 2x to the negative fifth. Adjust the form, adjust the power to be 1/2 x to the negative, x to the power 2 now. Okay, adjust the negative power, negative 3 minus 5, that becomes positive 2. Then the U2, which is antiderivative of 1/2 x to the second with respect to x, or 1 over 2 times 3, or 1 over 6 x to the third power. Okay, I'm gonna add more. Yeah, where's my mouse? Hang on a second. So this is x to the third. And then the last step, just to wrap up, step number 5 is nothing, put pieces together. So yp is u1 y1 plus u2 y2. U1 is, don't go. So u1 is negative x to the fifth over 10 times y1. Y1 is x to the negative third power. And then plus the u2, which is 1 over 6 x to the third, multiplied by y2, which is x to the negative first. And what you would do, just to clean up the power, to be negative 1 over 10 x to the second. And the second term would be 1 over 6. Again, x to the second. How nice. What you have to do next is combine the coefficient negative 1 over 10 plus 1 over 6 with the common factor x squared. And then we should get negative 6 plus 10, which is 4 over 60. So we get 4 over, this is from negative 6 plus 10 over common denominator. So we get 4 over 60, which is 1 over 15 x to the second power as the simplified form of the yp. And then the solution for this problem, which is y equals yc plus yp, or the form of c1 x to the negative third plus c2 x to the negative first plus the yp, or 1 over 15 x to the second.